Okay, so still going on with slope here. So slope of y equals mx plus b. We'd already talked about this, but the sign of that line is going to be b. We had already said this, that particular line, let me get my highlighter instead. There we go. We said that this form here, this was called your slope-intercept equation. So I've also heard it referred to as slope-intercept form. Because there are several ways to write a linear equation, this is just one of the many forms of it. So that's why a lot of times we use the form instead of equation. As we said, when we look at this, we know that the slope is going to be m, and our y-intercept, which we already discussed, is going to be 0b. So if we're given the equation of the line, we are actually, or especially if we're given a slope-intercept form, we're given all the information we need to actually just graph this. So just an example, we want to find the slope in the y-intercept. So as we see, we are in slope-intercept form. Y equals mx plus b. This tells me that this is my m. That's on the x. So my slope is going to be 3/5. And then my intercept, am I right? This is slope. So we know what I'm finding here. And then this is going to match up with this. So if you remember before, if it's a positive, then the intercept's positive. That's a negative number. The intercept's negative. But we have either y equals -4, or we say we have the ordered pair 0 minus 4, because that's going to be my b. And that is going to be intercept. More precisely, it's your y-intercept. I was being lazy again. So that's my solution. So once again, these ones are in a little different form here. So like we did last time, to find your slope and y-intercept, that means that we're going to need this to be in slope-intercept form. So I want you to take a minute and try to get them into slope-intercept form so then you can identify that slope and identify that y-intercept. Okay, so hopefully you did take a minute to try to work on these. B may have seemed a little weird. But anytime you want to get to slope-intercept form, sometimes you might be in it, but if you're not, you always solve for y to get your slope-intercept form. So I didn't exactly tell you that right away. I wanted to give you a minute to think about that, what you needed to do. But it's essentially what you're doing is you're just solving for y. So if I take this one and I solve for y, well, we're going to have to subtract -4x from both sides, which is going to leave me with a -7y. If you want, you can make it -4x plus 2. You can write 2 minus 4x. But at this point, we have to divide everything by -7. So after I do that, I'm left with y equals -4x over -7 plus 2 over -7. So what you can do here is that this is just a fraction. These negatives cancel each other. So you're just left with 4/7 times x. You just a way of rewriting that. So we have our slope. And then this here, we have that negative. So we can just say that's a -2/7. So intercepts aren't always nice numbers. Sometimes they do end up being fractions, as we have in this case. So we have slope, which is my m. That's going to be 4/7. And then my y-intercept, well, that's just going to be an ordered pair. We'll write it as the ordered pair, but it's going to be 0. And then remember this here is that intercept, -2/7. All right, so it's equations like this here. It's why sometimes we don't actually use slope-intercept form. Sometimes we like to write them like that because we don't like the fractions. That's why you see different versions. Okay, so for B, a similar thing, we just need to solve for y. Well, this is going to be easy. We just divide both sides by 5. So we're going to have 4/5 x equals y. And I know a lot of people don't like it in this way, especially if you're like dyslexic or you have problems with orientation in space. You can just, if you don't like your y being second, you just flip it because that's an equality. It doesn't matter what side of the equality you're on, just as long as we just move this all over here and this all over here. That leaves me with 4/5 x. So we see, because this is going to be my slope, that's 4/5. If we want to talk about that intercept, we don't have one necessarily on there. It doesn't mean it doesn't exist. Think of it as like there is a 0 added on here. What we're saying is that, as you saw with those first problems that we did like y equals 3x and we looked for the intercept, we got that 0.00. This is telling me that intercept is either you say y equals 0 or it's 0 and then, this is your B, so it'd be 0, 0. All right, one last one. So this is all set to 0. So this is like a standard form. A lot of times when we have standard form, we try to get rid of fractions. Or general form, try to get rid of fractions. We try to set it to 0. So in this case, what we're going to do is we want to isolate y again. So I can add 5 over here and I get 5x plus 2y equals 5. Then I can subtract the 5x from both sides. And now I have 2y equals 5 minus 5x, which is perfectly fine to write it that way. Then we have to divide everything by 2. My 5x up here. So we end up with y, and then we have 5/2 minus 5/2 x. Make sure I didn't make a mistake there. So if you want to, we can write the x term first. But here we get a negative slope. So my slope here is going to be negative 5/2 because that's what's on the x. And then my y-intercept is a 0.0 and 2/2. So I just want to point out, sometimes when you have a negative slope, you will see your linear equations written like this. This especially happens in certain courses like I'm trying to think, statistics. Statistics is a common place this happens, but you'll see this sometimes that when you have a negative on your x or on your slope, then they were going to write it in this way instead. That's fine because you can still write it this way as well.